So the second type of conic section is the parabola. The parabola is defined as the set of all points x and y in a plane which moves so that it is always the same distance from a fixed line and a fixed point. The axis of the parabola is the line through the focus. This is the focus, which is perpendicular to the directrix. This is the directrix. This is the vertex. The line through the focus parallel to the directrix is called the latus rectum. So this is the latus rectum. The point midway between the focus and directrix is called the vertex. So this is the vertex at the middle of the focus and the directrix. A parabola can be opening upward, downward, to the left or to the right. So this is a parabola opening upward, parabola opening downward, parabola opening to the right, and the parabola opening to the left. There are two cases to consider when talking about parabolas. So we have parabolas with vertex at the origin. So the vertex is at the origin of the Cartesian plane or the coordinate system. And we also have parabolas with vertex not at the origin. So the vertex could be anywhere in the coordinate system. So let's start with the standard form of the parabola when the vertex is at the origin. So if it opens upward and the vertex is at the origin, this is the standard form, x squared equals 4ay. While if it opens downward, this is the standard form, x squared equals negative 4ay. On the other hand, if it opens to the right and the vertex is at the origin, the standard form is y squared equals 4ax. And if it opens to the left and the vertex is at the origin, the standard form is y squared equals negative 4ax. So see the difference. If it opens upward or downward, it is x squared. While if it is open to the right or to the left, it is y squared. So let us remember this. These are the variables that we will going to use on our future, on the succeeding topics. D is for directrix. Directrix is a line. V is for vertex, it is a point. F is for focus, it is also a point. LR for the length of latus rectum. And A is the distance from vertex to focus. So this is what we're going to use, the pattern that we will going to use to find the critical points of the parabola if the vertex is at the origin and the axis is horizontal. If the axis is horizontal, the parabola could either open to the right or to the left. So here is the pattern. Vertex is at 0, 0. Focus is at A0. The directrix is at x equals negative a. The endpoints of the latus rectum are, first is endpoint 1 is at a, 2a, and the second endpoint is at a, negative 2a. And again, the standard form is given by y squared equals 4ax. If the axis is on vertical, or it could be opening upward or downward, this is the pattern. Vertex is at 0, 0. Focus is at 0a. The directrix is at y equals negative a. The endpoints of the latus rectum are, first, endpoint 1 is at negative 2aa, and endpoint 2 is at 2aa. And the standard form is given by x squared equals 4ay. Okay, so let's try some examples of finding the coordinates of the vertex, focus, endpoints of latus rectum, and the equation of the directrix. So again, this is how a parabola looks like. We have vertex, we have focus, we have endpoint 1, we have endpoint 2, and we have the directrix. So example number 1. Give the coordinates of the vertex, focus, endpoints of latus rectum, and equation of the directrix of the parabola x squared equals 8y. So looking at the given x squared equals 8y, we can say that the axis is vertical using the pattern that we have earlier. This is the pattern. So the axis is vertical because the standard form starts from x squared. Okay? So the first thing to do is to solve for a. And a can be found on the numerical coefficient of y. 8 is for a, but we are only looking for a, so we have to divide 8 by 4. So 4a equals 8 divided by 4. 8 divided by 4 is 2, meaning our a is 2. Okay, so using this pattern that we have earlier, our a is 2. So we will going to substitute a on every a on our pattern. Okay, so the vertex is given at 0, 0. The focus is at 0a, so it is 0, 2. The directrix is at y equals negative a, so it is y equals negative 2. Endpoint 1 is at negative 2a, a. Negative 2a, which is a is 2, negative 2 times 2 is negative 4, and then a, 2. And for endpoint 2, we have 2a, a. So 2a, a is 2 again, 2 times 2 is 4, and then a is 2. And then we have the standard form, which is x squared equals 8y. Now we have the critical points. We can graph the parabola. Okay, so here are our answers. So a, vertex is at 0, 0. The focus is at 0, 2. So 0, 2. So here's the focus. Directrix is y equals negative 2. Again, it is a line. So y equals negative 2. It can be found on the y-axis, negative 2. So draw a line. So that is the directrix. Next is endpoint 1 is at negative 4, 2. So negative 4, 2. That is endpoint 1. And endpoint 2 is at 4, 2. So this is endpoint 2. After plotting the points, we can now sketch our parabola. Starting from the vertex, passing through the endpoint 1, and passing through endpoint 2, we can form a parabola opening upward. Okay, so take note of this. The opening of the parabola always follows the direction of the focus. So, wherever the focus is, that is where the opening of the parabola can be found. Or, the focus is always located inside the opening of the parabola. And the directrix is opposite of it. Another example, give the coordinates of the vertex, focus, endpoints of latus rectum, and equation of the directrix of the parabola y squared equals negative 16x. Okay, using the given y squared equals negative 16x, it started from y squared, therefore we can say that the axis is at horizontal, given the pattern that we have earlier. So again, solve for a. A can be found here on the numerical coefficient of x. So negative 16 is our 4a. So we have to divide negative 16 by 4 to get a alone. So negative 16 divided by 4 is negative 4. So we have a is negative 4. So now we can solve for the coordinates of the following. So we will going to use this pattern. Our a is negative 4, so our vertex is at 0, 0. Focus is at a0, so it will become negative 4, 0. The directrix is at x equals negative a, so x equals negative, and then our a is also negative 4, so negative times negative is positive 4, so our directrix is at x equals 4. Endpoints of latus rectum, endpoint 1 is at a, 2a. So our a is negative 4, and then 2a, which is 2 times negative 4 is negative 8. And then endpoint 2 is at a, negative 2a. So again, we have a, which is negative 4, and negative 2a. Negative 2 times negative 4 is positive 8. So these are the critical points. Now it's time for the graph. So the vertex is at 0, 0. The focus is at negative 4, 0. So negative 4, 0. This is the focus. The directrix is at x equals 4. So it can be located on the x-axis, x equals 4. Then draw a line. That is the directrix. Next is endpoint 1 is at negative 4, negative 8. Negative 4, negative 8. Here is our endpoint 1. And endpoint 2 is at negative 4, 8. And then after plotting the points, we can sketch the graph starting from the vertex. Again, the focus is at the left side. Therefore, we can say that the parabola is opening to the left, because the focus should always be inside the parabola or inside the opening of the parabola. So from the vertex going to the endpoint 1, and from vertex passing through the endpoint 2. So this is the graph of our parabola. Example number 3. The focus of the parabola is at f negative 3, 0. So the given is the focus. If the vertex is at the origin, so if the vertex is at 0, 0, 0, 0, solve for endpoint 1, endpoint 2, the directrix and standard form of the parabola. So this time the given is the focus and the vertex. Given the vertex negative 3, 0, using the pattern A0, because 0 is at y, we can say that the axis is at horizontal. And we have A, which is negative 3, using the given negative 3, 0. So we will use this A, negative 3, 0, and this pattern axis at horizontal to find endpoint 1, endpoint 2, directrix, and standard form. So endpoint 1, we have vertex, we have focus. Endpoint 1 is at A to A. So A is negative 3, and then 2A, 2 times negative 3 is negative 6. While endpoint 2 is at A, negative 2A, A is negative 3, negative 2 times negative 3 is positive 6. And then the directrix is at x equals negative A. X equals negative A, negative times negative 3 is positive 3. And the standard form is given by y squared equals 4ax. So we will also going to substitute a, which is negative 3, on 4a. So y squared equals negative 4 equals positive 4 rather, times negative 3 is negative 12x. So the standard form of this parabola is y squared equals negative 12x. For the graph, the vertex is at 0, 0. Focus is at negative 3, 0. Endpoint 1 is at negative 3, negative 6. And endpoint 2 is at negative 3, 6. Anyways, endpoints 1 and endpoints 2 can interchange in label. And then the directrix is at x equals 3. So at the x-axis is 3. So draw a line here. So that is the x-axis. And then plot the points. So after plotting the points, sketch the graph from vertex passing through endpoint 1 and passing through endpoint 2. So we have a parabola opening to the left.